This problem will be for you folks to try in a moment, but I need to explain a few things, partly because my picture is not very good, and partly because I didn't write down all of the details. So Maude is in a plane. That is a plane. That is Maude looking out the window. I realize this isn't necessarily obvious from the drawing. The plane is flying at a constant elevation, 2 miles above the ground. And Harold is lying on the ground here. He's perfectly fine. Don't worry. He's just lying down because that's a comfortable position. And he's watching the plane fly away. And we're letting theta here be the angle of elevation. So that's the angle that he has to lift his eyes in order to be able to see the plane. Angle of elevation is always the angle that you make with the ground. Okay? All right, now we aren't told whether this is a happy or a sad occasion. We don't know if Maude is fleeing the country because the police are still chasing her after her prison break. We don't know if Harold is helping her and he's going to stay in touch, or if he's just happy to see her go and this is a good riddance sort of situation. I'll leave you to fill in all of those details. Okay. Your other task is that we are told that when this angle of elevation is 45 degrees, it's decreasing at a rate of 60 degrees per minute. Now, I purposely gave you things in degrees. You will have to convert to radians because the derivatives of the trig functions, those formulas that we know, assume that we are measuring things in radians. If we measure in degrees, we would get a multiple of those formulas. So you've got to convert to radians before you do this problem. And then we're asked, how fast is the plane if it's flying at a constant speed? So basically, this plane is staying 2 miles above the ground. It's flying at a constant speed. I want to know what that speed is, and I'm giving you this information about the angle. Okay. With a reminder to convert into radians anytime you're doing calculus. Go ahead and answer that question for me. I'm just going to complete this triangle here. If I drop a perpendicular from the plane to the ground, then I've got a triangle like so, where this would be where Harold is. So that's the angle of elevation theta. This would be the plane up here where Maude is, so I know that that vertical distance is 2 miles. And although the plane's actually up here, so the plane will be flying up along this track, notice that this distance down here on the ground, which I can almost envision as the distance that the shadow of the plane has moved, is going to be the distance that the plane has traveled since it passed directly over Harold. So I'm just going to label that as P. If I can figure out how fast P is changing, that's going to be the rate at which the plane is flying. Okay, so it looks like I've got an angle, the opposite side, and the adjacent. So once again, I could just use tangent. I could say tangent of theta is 2 over P. And I think I'm going to rewrite that as tangent of theta is 2 P to the negative 1. If you preferred, you could have used cotangent, and then the P would be on top. That's another perfectly acceptable choice. I'm going to go ahead and keep going with tangent. Okay. And so theta and P are both functions of time. I'm told how fast theta is changing. It's just in the wrong unit, so I'm going to have to convert. And I want to know how fast P is changing, because how fast this is changing is how fast the plane is flying. So I'm going to take the derivative with respect to time of both sides. Derivative of tangent of theta equals the derivative of 2P to the negative 1. So this will be implicit differentiation, or chain rule, secant squared theta times theta prime. This is going to be implicit differentiation, or chain rule, negative 2p to the negative 2 times p prime. Okay, excellent. So I'm going to need to plug in some information. Okay. So for the theta at this moment in time is 45 degrees. I know that's pi over 4, but what I'm doing with the theta is just plugging that into secant. That's not actually doing any calculus. So it doesn't matter whether I keep that as degrees or radians. I'm probably going to think of it as pi over 4 just to be consistent and do all of my work in radians. But the theta prime, I was given that in degrees per minute. That's a derivative. That's using some calculus. That I'm going to have to convert. Okay, so let's calculate these things. Secant of pi over 4 is actually just root 2. Okay. That's because cosine of pi over 4 is root 2 over 2. Okay. So secant would be the reciprocal of that. But if I rationalize that, I'm just going to get 2 root 2 over 2, which is root 2. So secant of pi over 4 is root 2. That's going to mean secant squared is actually 2. Let me actually just copy this up here. We need secant squared theta times theta prime equals negative 2. I'm just going to write that as over p squared times p prime. So we've just gotten that secant squared theta is going to be 2. Secant is root 2. If we square it, we will get 2. Now, theta prime we have, but in the wrong units. Okay. So theta prime is, let's see, we were told the angle is decreasing, which makes sense as the plane flies further away. So it's going to be negative 60 degrees per minute. And we need to convert from degrees to radians. So I want the degrees to cancel, so I'm going to use the fact that 180 degrees, which is half of a revolution, would be pi in radians. That way those degrees will cancel. 60 cancels with 180, and so this becomes negative pi over 3 radians per minute. And then we've got negative 2 p. We're going to need to figure out at this particular moment in time. But we care about the moment in time when this is 45 degrees or pi over 4. At that moment in time, this is an isosceles triangle, so the two legs are the same. So p would equal 2 at that moment in time. So p squared would be 4, and then we get p prime. All right. So just coming over here, that's negative 2 pi over 3 equals negative 1/2, reducing that negative 2/4, p prime. Multiply both sides by negative 1, p prime is 4 pi over 3. Okay, excellent. So that's the math answer. Let's see, how fast is the plane going? We want to just answer that in English. The plane is flying at 4 pi over 3. And the units would be the units for p. That was a distance. We were measuring distances in miles, divided by the units for time. We were measuring time in minutes, so 4 pi over 3 miles per minute. Okay. Now, that's slightly unusual units. I didn't specify what units to use, so that's perfectly acceptable. If you wanted to convert that to miles per hour, you'd simply multiply by 60, because there are 60 hours in 1 minute, and that would be fine as well.